Hi everyone, this is Jack from Maths Forge, and in today's lesson we're going to be doing bounds. So let's take a look at our first example. Here we're being asked to find the lower bound of 1.9 to 1 decimal place. Now this 1 decimal place here is a very important part of the question. When you are finding a bound to 1 decimal place, or to actually any degree of accuracy, this 1 decimal place, we're going to take it and we're going to write the base value of 1 decimal place. The base value of 1 decimal place is 0.1. The base value of the nearest integer or unit is 1. The base value to the nearest 10 is 10. And actually the base value to 2 decimal places will be 0.01. So these ones are very important, and they will allow you to determine how to find the lower or upper bound of any number. In this example, since we're dealing with 1 decimal place, so we're going to use 0.1 as our base number. You take your base number of 0.1, which we get from 1 decimal place. You then divide it by 2, which is going to give us 0.05. You take this and you add or subtract it to the number that you're finding the bounds of. You add it if you want to find the upper bound, and you subtract it if you want to find the lower bound. For this question, we're finding the lower bound of 1.9. So we're going to take the 0.05, which we found from this 1 decimal place here, and we're going to subtract it from 1.9. This is going to leave us with 1.85. And if we check our answer, there it is. So essentially, bounds is like the reverse of rounding. For bounds, you're essentially answering the question of what's the lowest possible number this 1.9 could have been rounded up from, or rounded down from. If you're finding the lower bound, you're finding the lowest possible number that this number could have been rounded up from. And in this case, 1.9 could have been rounded up from 1.85. If we do another 1-star example, here we're being asked to find the upper bound of 320 to the nearest 10. So nearest 10, so our base value here is going to be 10. We're going to divide it by 2. We're going to half it. You're always halving your base value. This gives us 5. And then this 5 that it gives us is going to be the number we add or subtract to find the upper or lower bound of 320. So we take 320. We're finding the upper bound of it. So we're going to add this 5 onto it. And this is going to give us 325. And this is the upper bound of 320. If we check our answer, there it is. Now we'll do a 2-star example. We're being asked to find the bounds. So it's not asking you for the upper or lower, it's just asking you for the bounds. So we have to find the upper and the lower bound of 93. To the nearest integer. The nearest integer, or the nearest unit, just has 1 as a base value. And so we take this base value of 1 and we divide it by 2, which gives us 0.5. Now to find the bounds of 93, we take half of our base value, which is 0.5, and we subtract and add it onto 93 to find the lower and upper bounds. So for the lower bound, 93 minus 0.5 is going to be 92.5. This is the lower bound of 93. And 93 plus 0.5, this is going to give us 93.5, which is the upper bound of 93. So our bounds are 92.5 and 93.5. And if we check our answer, there it is. This is just another way of writing the number that we're dealing with, which is n, in this case is 93, has bounds of 92.5 and 93.5. Now let's do a 3-star example. Here we're being asked to find the upper bound of 77 plus 65. So to find the upper bound of numbers being added together, we just simply have to find the upper bound of each individual number. So we're doing this to the nearest integer. So our base value is 1 and half of our base value is 0.5. So we're going to take 77 and we're going to add 0.5 onto it. We're going to take 65 and we're going to add 0.5 onto it. We're going to find the upper bound of each number. The upper bound of 77 is 77.5 and the upper bound of 65 is 65.5. And now since we're adding these numbers together, this should give us the upper bound of this calculation, which is going to be 143. And if we check our answer, there it is. We'll do another 3-star example. Here we're being asked to find the lower bound of 9.2 times 5.4, rounded to 1 decimal place. So our base value here is 1 dp, so it's going to be 0.1, and half of our base value is going to be 0.05. Now, to find the lower bound or the upper bound of numbers that are being multiplied together, to find the lower bound, you just find the lower bounds of each individual number and then multiply them together. To find the upper bound, you find the upper bound of each individual number and then multiply them together. But in this case, we're finding the lower bound. So we're going to do 9.2 minus 0.05, which will give us the lower bound of this number, which is going to be equal to 9.15. And to find the lower bound of 5.4, it's going to be 5.4 minus 0.05, which is going to give us 5.35. And now this is the lower bound of each individual number. We are now going to multiply them together. So 9.15 multiplied by 5.35. And using a calculator or a method of multiplication, this should give us 48.9525. And if we check our answer, there it is. And that's it for our lesson on bounds.